Okay, so let's start with number 2. It asks us to determine whether or not, whether the function approaches positive infinity or negative infinity at negative 2 from the left and from the right. And this question hinges on the fact that there are going to be vertical asymptotes on these functions at negative 2, right? That's the only time that we're going to see limits at infinity or negative infinity, only at vertical asymptotes. So that's kind of good to remember. And clearly for this function, there's going to be some problem at negative 2, because negative 2 would cause us to have a 0. So there we have a vertical asymptote at 0. So let's talk about A. It doesn't really break it up, A and B, but this is from the left. So from the left, what's happening? So on the left of the vertical asymptote of negative 2. And from here I'm coming in and I am shooting off into negative infinity. That's what's going on. And part B, from the right, I'm coming in from the right and it's shooting off to positive infinity. Okay, simple as that. Next, let's go on to number 9. F of x equals 1 over x squared. Okay. Find the vertical asymptote. That's all we're doing, no limits, nothing like that, just find the vertical asymptote. Of course, you have a vertical asymptote here when the denominator goes to 0 and this whole thing blows up. And where that happens, well, let's see, where does this thing equal 0? When does that happen? Take the square root of both sides, and whenever x is 0, when you square it, you get 0, right? So this is going to have a vertical asymptote at 0. And that's that. Now let's go to 11. H of x squared minus 2 over x squared. Lost it for a second, but don't worry, I found it again. So find any vertical asymptotes. Vertical asymptotes happen when the denominator, which is this, is equal to 0. So let's find out when that happens. It's a polynomial, so to solve for x, I would say let's factor it. Let's get an x here and an x here. Probably a positive 1 and a negative 2. That seems to have worked. So whenever x is equal to negative 1, or x is equal to 2, then we have the denominator being 0, and we have vertical asymptotes at those points. Okay, let's try number 12. Okay, make sure I've written down the right one here. Now, where does this denominator equal 0? We could set up this equation. So it must be when x squared equals 0, or when 1 minus x equals 0. So whenever x equals 0 or x equals 1, then we have a problem. And that's it. That's when we put these numbers in, the denominator is 0, and we have a vertical asymptote when that happens. Okay, number 30. Okay, so all of these apparently have been engineered to have problems at x equals negative 1. We're going to investigate. Right, so if I put in a negative 1, I'm going to have an issue. But now, this new element of the problem is this problem is this issue at -1 going to be a vertical asymptote, or is it going to be what we're calling in this section removable discontinuity, or a hole? Where do holes happen and where do vertical asymptotes happen? Well, they both happen when the denominator is 0. Well, let's talk about removable discontinuity. Removable discontinuity happens where the denominator has a common factor with the numerator. And vertical asymptotes happen where there aren't any common factors. So let's move this up just a little, give myself some room. Alright, let's factor this guy. Let's see, this must be a plus 1 and a minus 7. Okay. So now we're trying to figure out, is it removable discontinuity, or is it a hole, or is it a vertical asymptote, excuse me. Here we are, x plus 1 and x plus 1, common factors. That is where removable discontinuity happens. So let's just call it removable discontinuity, RD. Let's try 42. And with 42, we just want to find the limit. That's all we want to do. Which kind of rolls everything into one, We've got to be able to find vertical asymptotes if they exist, and then we need to, as we talked about in a previous video, not get tricked into thinking it's a vertical asymptote when it's not. Alright, so we could have it go to infinity, negative infinity, it might be a single value. Okay, so what's going on with this function at 0? Well, if I put in a 0 here, I get 0. That's fine. 0 is a fine number to have. But then I'm dividing by 0 over here, and that's no good. And we can already see this is going to have to be a vertical asymptote because there's no common factor of x between the numerator and denominator of this fraction. So just forget about that. So what's happening as we're approaching 0 from the left, is it a shape like this that comes down, or is it a shape like this that goes up? And you could graph it and you could look at it, but you might as well have not learned how to factor the denominator and identify common factors and all that kind of stuff. So what we're going to do is we're just going to have to investigate this function and figure out what's it doing as it gets really close to 0. And previously I was having you plug in values and see what those values are doing, but it turns out for this function I tried putting in -2 and -1, and this is what happened. I got a -2, and I was somewhere up here, and then at -1 I was somewhere right here, and so those numbers would lead you to believe, oh, it's going to continue this trend and keep going down like this. But what actually happens is right at 1 it starts, or in between 1 and 0 it starts to pick back up, and then it shoots off in this direction. Okay? So what we need to do is just kind of think about this. And we could look at it like this, or we could put it together, add these together and make them a single rational function. Between the two, I think this might be a little easier to think about, right? Because one thing, this number is always going to be positive, and so this is really the only factor. So let's think about this. Right, so I'm going to put in values that are really close to 0 into both of these x's. And here, when I do that, I'm just going to get this value that's really close to 0, even closer to 0, because I'm squaring it. I'm taking a small number and multiplying it by itself, and it's really tiny. Really tiny, tiny negative number. Okay? Then I'm going to subtract this thing. Okay, so we get this tiny negative number minus this thing. Let's talk about this thing. I'm going to put in values that are negative, they're to the left of 0, and they're very small. Very small negative numbers. Well, what happens when I divide by a very small number? It gets very big. Very, very big. So I've established that part. 1 divided by a small number is a very big number. But remember, this was a negative number. So it's 1 divided by a very small negative number is a very large negative number. Okay, so this is a very large negative number, and I'm subtracting it. Subtract a very large negative number, you're adding a very large negative number. Add a very large negative number to a tiny, tiny number. It doesn't matter if this is positive or negative. You're adding a huge number, a huge positive number, to an insignificant amount. So you're going to get huge positive numbers. That's what's going on here. Out here, this is going to outweigh, you know, this little thing as we get this direction. And so that's why we get this downward trend. But as we get closer, this one's going to take back over. They're going to kind of level off right here, and then this one's going to take over and become the driving force to bring it back up. So that's a look at that. We just kind of have to use our thinkers on that one. Or, like I said, you can graph it and give up and rely on that. Rely on your calculator, and it'll get you through, and you'll get the right answers. But you'll be empty inside, so don't do that. But that's the last one for this section. So hope that was helpful. I'll see you next time.